Welcome to Math 150, review for test number 1, sections number 7 through 10. 7 is solving application problems involving linear equations using a systematic approach. Those are the word problems that we've done in our discussion and other homework. I'm not doing many word problems here in these reviews. Number 8, solve formulas for specific variables. So given an equation, you're to find a certain variable. So 3k plus L is the same thing as H. When we're asked to solve for k, that means tell us what the equation looks like when written in terms of k equals. So the same process for solving equation applies. Do whatever you want to both sides of the equation. The goal is to isolate that k, so do whatever you want to both sides that will help you reach that goal. So the left side becomes 3k plus 0. And now this multiplication of 3 is in my way, so I will do that to both sides of the equation. Basically, if we give you alphabet soup and ask you to solve it in terms of a specific variable, we are expecting alphabet soup back. We're expecting an equation with a bunch of variables. And that's it. That's what the answer looks like. B, solve for J. Given J, K, H equals 5, your goal is to get J by itself. What's blocking that goal is the fact that it's being multiplied by KH. So you divide both sides by KH. Your final answer, J, is the same thing as 5 divided by K times H. Solve for X. Three times the quantity X plus Z equals Y. Notice in algebra, capital letters and lowercase letters are not the same. Distributive property works. Now I want X by itself, so this 3Z is in the way. So I will subtract 3Z from both sides. And I'm left with 3X is the same thing as Y minus 3Z. Opposite of multiplying is dividing. So there's your final answer. Remember, you can fast forward or pause the video at any time if you need more time or if you've already understood the concept and want to move ahead. D, given the equation perimeter equals twice the length plus twice the width, solve for L, length. My goal is to isolate the L. So the first thing I'll choose to do is subtract 2W from both sides. Twice the length is the same thing as the perimeter minus twice the width. I want L isolated. Multiplication is blocking that goal, so the opposite of multiplying is dividing. So my length is P minus 2W over 2. Final answer. Solve for R. Diameter is twice the radius. D equals 2R. Solve for R, or the radius. Do whatever you want to both sides. D divided by 2 is the same thing as the radius. Those are your final answers. And that's what Alex would be looking for. 9, more solving. Again, solve means tell me the values that will make the equation true. Right, to solve inequalities, it's the same process as if you're solving an equality. The only difference is if you multiply or divide both sides of the inequality by a negative, you change the direction of the inequality. When you're solving an inequality, you're going to solve using the same process as solving an equality, except when you multiply or divide both sides of your inequality by a negative number, that's when you flip the direction of your inequality. For example, 3x divided by 15. My goal is to isolate the x. So if I choose to divide both sides by the coefficient is the number in front of the x, then I would be left with x, and 15 divided by 3 is 5. Positive divided by negative is negative. But I am going to flip this sign here because I divided both sides by an inequality. So I would write the inequality going the other direction. And this would be my final answer. In contrast, the green problem is 3 times x less than or equal to negative 15. In this case, I again choose to divide both sides by the coefficient. In this case, my coefficient is a positive 3. So because I am dividing both sides by a positive number, I do not flip the inequality. And my answer would be x is less than or equal to negative 5. Again, in the first purple example, I have a negative 3 times x is less than or equal to 15. So I divide both sides by a negative 3. I flip the inequality. In my green example, I have a positive 3. So I divide both sides by a positive 3. I'm still left with a negative 5 as my answer, but my inequality does not flip because what I did to both sides was divide by a positive 3. So these are 2 different problems with 2 different solutions. There's the equation. And then if I were to write it in set builder will look like the squiggles for set notation. Tell the reader which variable you're using, and then copy the equation. There's my set builder. For my green equation, the set builder is the set of all numbers x such that, this vertical line means such that, x is less than or equal to negative 5. That's your set builder notation because it uses the squiggly set. And then to graph the equation, I want all of the x values greater than or equal to negative 5. My graph must have 2 points on it so that we know where all the other points are on the line. So x greater than or equal to negative 5 means negative 5 does not make my equation true. All of the numbers greater than negative 5 will. So it will go off and to the right. Do an open circle and to the right. Then to do interval notation, I would have a parenthesis to show the readers that the negative 5 is not included, and then it's getting larger towards positive infinity. So that would be interval notation. And then do the same for the other. x less than, so I'm going to let my -5 is here, 0 is here, x less than or equal to, or equal to, my bad, I'm sorry. Or equal to means the endpoint is included. And then for interval notation, we put a bracket to show that the endpoint is included. X less than or equal to -5 means all of the values of -5 and everything smaller going toward -infinity. So my interval notation, we always put the smaller number on the left, the larger number on the right for our interval. The bracket tells us the endpoint is included. The parenthesis says it is not. So given these two original equations, the purple is -3x less than or equal to +15. The green equation is 3x is less than or equal to -15. I've shown you the answers using set builder notation, interval notation, and graphing. All right, now to do the examples. All right, so again, when solving an inequality, it's the same as solving an equality, except for when you multiply or divide both sides of an equation by a negative. All right, when solving an inequality, solve using the same process as solving the equality, except when you multiply or divide both sides of an inequality by a negative number, you change the direction or flip the inequality sign. We're supposed to show set builder notation, graphing notation, and interval notation. I'll demonstrate all three. Nine one. Solve and graph the solution set. Write the solution set in set builder notation and interval notation. Do whatever you want to both sides of the equation. I'm going to first isolate the variable. So I'll choose to subtract 3 to both sides, from both sides. My inequality, I'm only adding or subtracting, so the inequality is still in the same direction. So I'll have 4. On the left side, I'll have 2x. I'm now dividing. As soon as I'm dividing, I stop and ask myself, do I need to change the direction of the sign? The answer is no, because I'm dividing by a +2. So I'm looking for x greater than 2. Those are the solutions to this equation. So if I use purple and I put a dot up here on my number line, 2 is a point of interest. So if this is the location 0 and this is the location 2, I need all of the numbers x that will be greater than 2. So that means 2 is not an answer, but 2.001, and all of the numbers larger than 2, fractions, decimals, everything are larger. Once I put a dot on each of those numbers on the number line, it looks like a ray. So there's my graph, my set builder notation will be the set of all numbers x such that x is strictly greater than 2. There's my set builder. My interval notation will be all of the numbers from 2, but not including the number 2, up to infinity. To the right is positive infinity, to the left is negative infinity. Infinity is not a point, so you will always have a parenthesis in your interval notation whenever you have positive or negative infinity, and the other number will be a bracket if the endpoint is included, or parentheses if it's not. Number 2. 15 is less than or equal to 5 times our mystery minus 35. So I'm going to here first add 35 to both sides of the equation. I'm adding or subtracting. So if this were a teeter-totter out on the playground, it would not change if I added 5 pounds or 35 pounds to each side. So I copy the inequality, simplify the right side. 15 plus 35 is 50. Now I want x by itself. What's blocking my goal is multiplying by 5, so I divide. Now that I'm dividing, I ask myself, do I need to flip the inequality? And the answer is no, because that green number 5 that I wrote down is a positive number. So my answer is 10 is less than or equal to x. It's best if you also know that that's the same thing as x is greater than or equal to 10. So to put this in set builder, I have the squigglies. I have squiggly, tell the reader which variable you're using, which is x, such that, and this vertical line here means such that x is greater than or equal to 10. That is your set builder notation. Now, interval notation, I'm going to graph. I need x greater than 10. Well, let me get 2 numbers on my number line. How about 0 and 10? So x greater than or equal to 10. So that means the number 10 will make my answer true. So I will put a dot there. The x values that are greater than or equal to 10 go to the right. So that means I'll have array to the right. Now that I have my graph, I can tell that my interval notation will be a bracket for 10, comma, infinity with parentheses. Sorry for the lawnmower. Number 3. 2 times the quantity 4x minus 8 is greater than or equal to 32. You can do whatever you want to both sides of the equation. Stop this. All right, number 3. 2 times the quantity 4x minus 8. You can distribute first if you want to. I don't want to. My goal is to isolate the x. The first thing I'm going to do is divide both sides by 2. So now I'm left with 4x minus 8 is greater than or equal to 16. Again, do whatever you want to both sides. That minus 8 is in my way, so I'm going to add. This is an inequality, so when I divided by 2, I needed to pause and think about whether I was going to change the direction of my inequality symbol. I don't need to. I'm not dividing by a negative, I was dividing by a positive 2. So I now have 4x is greater than or equal to 24. Again, I did not flip the direction of the sign because I'm only adding or subtracting. You never have to change it when you add or subtract. Now that I'm multiplying or dividing, I'm dividing by 4. So do I need to flip the inequality? No. And my answer is x greater than or equal to 6. There's the equation. Now to graph that, I need 2 points on my line, so I will pick 0 and 6. X greater than or equal to 6 means or equal to is on the line, and going to the right is bigger, so that's what my graph will look like. As you progress in ALEKS, ALEKS will end up eventually wanting you to use the bracket, and so point the bracket in that direction, and that will show x greater than or equal to 6. Okay, set builder. The set builder is the one with the squiggles. So I have the set of all x such that, and I'll close my squiggles, and what I put inside is the equation. X greater than or equal to 6. Interval notation. You're going to give me the interval of numbers that make the equation true. I think this is easiest read off of the graph. The graph is everything from 6, including 6, going to the right, which is toward positive infinity. And again, you always have a parenthesis next to your positive or negative infinity. So here is your set builder. Here is your interval notation. Here is your graph when the equation is x greater than or equal to 6. And that is the same equation as what we were originally given. We just rearranged it and simplified the original equation. Number 4, 3 times the quantity x minus 5 minus 6 is strictly less than 2 plus 4 times the quantity 7x minus 4. Do whatever you want to both sides of the equation, but in this case, I would first simplify each side. So I'll write my inequality so I don't forget it. I'll write down what I'm not using, which is the minus 6, and then I distribute the 3x minus 15. On the right side, I have 2 plus, and this plus goes with the 4. So I am multiplying positive 4 times positive 7, and I get a positive 28. That's all multiplied by x. And then positive 4 times negative 4 is negative 16. Simplify each side further. The left becomes 3x minus 21. The right side is 28x minus 14. I can do whatever I want to both sides. I'm going to subtract the 28 from both sides. And I'm going to also add the 21 to both sides. Notice I'm doing the same thing. I'm adding or subtracting the same values to both sides of the inequality. So that means my inequality will remain the same direction. The right side will simplify to become 7. The left side will simplify to become a negative 25x. My goal is to have x by itself. What's blocking that goal is the negative 25. So I divide by the coefficient. The number in front of the variable is your coefficient. Now, I just divided by a negative, so I will change the direction of my inequality. I'm now looking at x is greater than negative 7/25. And this would be the answer. Quick little thought bubble. 7 over negative 25 is the same thing as negative 7 over positive 25, which is the same thing as negative in front of the fraction, 7 over 25. Generally, it's nice to put the negative up in the numerator so the person reading your work knows immediately that it's negative. To graph this, is this graph up here. I need 2 points on the graph. I'll use 0 and negative 7/25. So if this point is 0 and this point is negative 7/25, well, this is a strictly greater than, so that means it will be an open circle. And I want the x values that are larger than that, so it would be everything going to the right. So there's my graph. My set builder is going to look like the set of all x such that, and then it's in squiggles again. And then you copy the inequality that you just reduced. The set of all x such that x is strictly greater than negative 7/25. My interval notation, give me the interval of numbers that make it true. It would be an open parenthesis of negative 7/25, comma, going on to positive infinity. So here's your set builder, and there's your interval. And again, the parenthesis next to the negative 7/25 is because my inequality does not include the equal portion. It's strictly greater than. All right, last one. All right, make sure you copy the inequality correctly. First thing I do is figure out where the equal sign is if it's an equality, where is the inequality sign if it's an inequality, and then rearrange things so it becomes more simplified. Left side distribute, right side 5 times 2 is 10. 5 times -1 is -5, and then copy the numbers you're not using. Do whatever you want to both sides of the equation. I'm going to subtract 6x from both sides. If my variables will end up on the right side, then I want my numbers on the left side. So I'm going to add 1 to both sides. I'm only adding or subtracting so my inequality stays the same direction. This left side simplifies to be 11. This right side simplifies to be 4x. Now the only thing blocking my goal is multiplying by 4. So I divide both sides by 4. I am dividing, but what did I write on both sides? I wrote a positive number. So 11/4 is strictly greater than x. You need to recognize that this is the same thing as saying x is strictly less than 11/4. Now that I have that graph, on any graph, you need to have at least 2 points. So everyone then can find the remainder of your points. So if I pick my points to be 0 and 11/4, then I need the x values that are strictly less than 11/4 and all of the other numbers. So once I put dots on that line, it's going to look like a ray going to the left. So there's my graph. My interval notation will be -infinity up to, but not including, the point 11/4. So I'll put a parentheses, and then set builder will be the set of all numbers. What's my variable x? The set of all x such that, and then copy your final simplified equation. X is strictly less than 11/4. So here is your set builder, your interval, and your graph. All right, section number 10 is solve the applications involving inequalities. This is the same thing we've done for discussion in week 2. Please look over those discussions. You have 25 examples in the discussion board. If you need more examples, email me or your instructor. Happy to help.